Alright, this is OEH 5723, homework 2, problem K. So I'm just doing a little screenshot of my own screen with the webcam, so maybe this isn't the best resolution, but we'll try to get through it. So we need to use Antoine's equation for this, and I'm asking you, using Antoine's equation, look these values up. I use the NIST chemistry web book. You can also use physicochemistry, physicochemical, or modern industrial hygiene. So I want you to plot the vapor pressure in torr of ethyl acetate from 50 Fahrenheit to 120 Fahrenheit. And I want you to use Excel because I'm asking you for a lot of data points and you just can't do this manually. And this is the sort of thing that Excel is really good at. So there's a certain level of complexity that you have to do, but once you get that set up, you are ready to go. So I'll move this out of the way. Now I've already pulled up the NIST physicochemical, the NIST web book. And so the Antoine equation is log P is A minus B divided by temperature plus C. And so these are our constants right here. And it tells us that this is also good for a temperature of 288 Kelvin to 350 Kelvin, 348.9. So I've got these values, A, B, and C, already input into my spreadsheet, A, B, and C. So I'm just going to check them out, 0.422809, that checks. 1245.702. 0.702, it's just not showing all the decimals. And then this one is negative 55.89. Alright, so I've typed those in correctly, and I've got the formula already transcribed here. So actually I think I can just leave that there, and I'll just check, see if you guys can see that. That should show up. Okay, so I've labeled some headings, some column headers already, just so that it will facilitate things. I suggest you do it this way. You don't have to do it this way. But our Antoine equation is going to be built right here. And this is going to be the output of Antoine's equation. Then we're going to calculate from Antoine's equation, we're going to d-log it, we're going to anti-log it, and then we're going to convert from bar to kilopascal, and then kilopascal to torr, so that we can plot our torr against our temperature. So let's start off with temperature. Temperature is 50 Fahrenheit, and I want to know it all the way down to 120 Fahrenheit. So I established a little pattern. Now I'm just going to drag it down to 120. Alright, I'll scroll back to the top. So here for Celsius, we can convert from Celsius by subtracting 32. So I'm just going to say this equals the Fahrenheit field minus 32, and then multiply it by 5/9. So I always forget, I have to put parentheses around this subtraction operation. Otherwise, the orders of operation will prevail and it will say 32 times 5 instead of the Fahrenheit field minus 32, and then that quantity times 5 divided by 9. So we had 32 something as our value, now it's 10, which is correct. So you're more than welcome to get online and look things up and verify that you're getting the right output. And so I do that, and indeed I do get the right output. So now we just need to convert Celsius to Kelvin, and that's easily done by saying this equals the Celsius field plus 273.15. Now I'm being precise because I've got Excel and it's going to do all this for me, so I just have to type it in one time and then drag it down. There we are. So now we have our temperatures in Kelvin. So this is what's going to be used for the Antoine equation. So remember, pressure is bar, and temp is Kelvin. Oops, bumping my camera here, sorry. Okay, so now we can build our Antoine equation. So this is equal to A, see, I've got it written out here, the log of P, and this column is log of P, is equal to A, so I'm going to go over here and select A, minus, And I'm going to go ahead and put my parentheses B, so there's B, divided by, and here's where I'll put another set of parentheses between the temperature plus Celsius. So parentheses, temperature in Kelvin, so temperature, plus our constant C. Alright, so that plus C. So I close the parentheses. You can see it's green parentheses because it's closing those parentheses. And I close them again, it's black parentheses. It's closing the denominator and it's closing that whole expression. So hit enter, and you should get something that is a negative number because we're talking about a fraction of an atmosphere. So I'm just going to scroll up. Alright, sorry. One last trick I forgot to mention is that each of these J references here for A, B, and C, they need to have little dollar signs in front of them so that it will stay put. So that as I drag this formula down, this is what happens. I get zeros because this formula is referencing A, B, and C. This field is, and that temperature. But this one down here, it's referencing B, C, and something else because Excel's trying to be smart and it's dragging all the relative references down the page. And so by the time I get down here, it's referencing nothing except temperature. So we don't want that. We need to make this absolute location so it will only go to that location, and these won't drag, but this one will. So my J1, J2, and J3 need to have little dollar signs, not at signs, but dollar signs before J, $J, $1. Alright, so this time I'll just do the $sign and $sign, and this time $sign and $sign. Alright, so now when we look at it, it still references, it hasn't changed those references. Those are still correct. But now I can drag this down, and as I drag it down, you'll see it's still referencing those same cells, but the temperature is dragging down. So that's what we want. Alright, that was the tricky part. Okay, so those are all of our log of pressures. So now we need to untransform it, and it's going to give us bar. So we're just going to say 10 caret, which is 10 raised to the what? Equals 10 caret this field. So the log of pressure. So we're anti-logging that. So now I just drag that down. Okay. Now we want to go from bar to kilopascal. So like I said, 1 bar equals 100 kPa. So we're going to say this equals bars times 100 kilopascals divided by 1 bar. So that's kilopascals. So basically 5,500 pascals. Now it might help you to work out this first one on paper and then transfer it onto Excel. So now we want to go from kilopascals to torr, and that's what I have sort of going on here, but really I should write it as 101.3 kPa equals 760 torr, right? Alright, so now we want to take our kilopascals and make them into torr. So this equals the kilopascal times our 760 torr, and that's 760 torr for every 101.3 kilopascals. And so that's how much torr we have in vapor pressure. So drag it down. Alright, so now it's just a matter of building our plot. So in Excel, we go Insert, and you've got these different kinds of plots. We'll do a scatter plot, and we can do a line plot on this one, a scatter line. So right click and select data, add. We can give it a name. We'll just call it vapor pressure of ethyl acetate. Alright, so my x-axis, I'm going to make temperature, so I can see how the vapor pressure changes with temperature. So what temperature did I ask for? I didn't ask for Kelvin, I asked for it in Fahrenheit. So I want to know how this changes. Now this is equal to this is equal to this. This is temperature, Fahrenheit, Celsius, Kelvin. Those are all the same thing, but just different units. Just like these pressures are all the same, but different units. So the Antoine expression will give you the pressure in bar, but you can convert that to something else. Now this is my Y series it's asking for, and so I asked you for your pressure in torr. So we use that column. And so that should be done. Well, I spelled it wrong, but that's okay. It's vapor pressure. So there we go. Vapor pressure. Vapor pressure of ethyl acetate. Alright, so it's important to label our axes. So you can see up here there's different little formats for how you want this to look. I am going to use this one. Ooh, not that one. Let's use that one. Okay, so I don't need that. We've only got one thing, so we don't need the legend. And I know that I'm only asking from 50 to 120C, so let's format the axis, and let's set our minimum to 50 Fahrenheit. Sorry, I said C, I meant Fahrenheit. And 120 Fahrenheit. And then let's set our major tick marks to cross, and our minor tick marks inside. Now for this is our vapor pressure, right? So, well, let's finish this axis. So this is temperature, and it's in Fahrenheit. And then this, I click on it, this axis is vapor pressure, and it's in what units? Torr. Alright, now we can label this. We can change it if we want. We don't really need to, though. I personally, though, don't like these, so I delete them. It makes a cleaner graph. But now we need to do the same thing when we format our axis. Sorry, that was a right click, format axis, and then up here for minimum, I'm not going to change. I'm just going to major tick marks cross, minor tick marks inside. So there you have it. That is what we're looking for, and that is all of problem K. Now you need to tell me where you got this. So I verbally told you that I got this information off of the NIST web book, but if you get it from Modern Industrial Hygiene or the Physical Chemistry manual, you might get slightly different values. So let me know. Alright guys, sorry that was kind of a long post. The next one will be a lot faster because we'll just work off of this.